We're going to get started right away. I know we just wrapped up the previous session. I'm Professor Frank Rudzicz, Professor at Dalhousie in Computer Science, Canada CFAR AI Chair at the Vector Institute. I'm very pleased to moderate the session on AI and health. We have 5 talks today. We're going to swap the order a little bit just because of some technicalities. So the person who was previously last is going to go second. I'm going to be, I'm going to be pretty strict today. There's a session right after ours. So I'm going to put a timer on for 17 minutes, which is going to include the presentation and questions. And there's going to be an annoying alarm that's going to go off. And at that point, I'm just going to remove you from the stage and get the next person on. Okay. So the first speaker is Yilin Huang. He's an undergraduate researcher at St. Mary's University. He has contributed to various critical open source AI infrastructures, especially at Hugging Face, where he is an active contributor. He also contributed to teaching materials for an agentic AI curriculum for a Master's of Business Analytics, which I think is maybe one of the first in the country. Whenever you're ready, go ahead.
I'm ready. Okay, can you guys hear me okay? Can you guys see the slide? Okay. First of all, before I start my presentation, I would like to sincerely thank the moderation service of Frank. Just today's morning, Frank told me that he's going to use the timer to control the time. And I take it as normal, common practice. But based on my today's experience, I just realized something very few moderators can do. If we have an award called Best Moderator, I'm going to nominate Frank, to be honest. Thanks for your moderation service and your professional manner of time control. I really appreciate that. Okay. Because of the mismanagement of time left by the last series, I will have to accelerate my presentation to mitigate the following damage to the next series. I will do it very quick. Okay. Today I'm going to present the work we have recently done, which is exploring applied agentic AI to improve MRI appointment scheduling. It's Yilin. The supervisor is Michael Zhang. Let's get started. Okay. So first of all, I'd like to mention the scope a little bit. The MRI scheduling in our real life will encounter way more problems that we can consider. So given our capacity and capability, we have to only consider a subset of identified issues. In case you're curious about it, the beautiful and the beautiful and appealing image in the first slide is generated by AI using Google Nano Banana 2. Here's the prompt. If you like it, you can take it and generate your own. Okay, introduction. So, MRI, or stands for magnetic resonance imaging, is a non-invasive way of taking high-quality images. And these images will help doctors to understand the condition of patient before taking any action. Due to the limited number of scanners in Nova Scotia, MRI waiting time is crazy long for non-emergency patients. So here's the news. A woman in Halifax calling out Nova Scotia Health after 7-year wait for MRI appointments. But at the same time, the hospitals also suffer from the long idle time of MRI scanners, which is roughly 30%. Therefore, improving appointment scheduling strategy can reduce idle time, therefore further reduce the waiting time. Okay, given the potential of agentic AI, we intend to explore agentic solution to optimize MRI scheduling. A little bit of background. The first one is the patient view procedural knowledge of MRI appointments booking. Set 0, if patient feels sick and believes they need to reach out to family doctor, then they will reach out to the family doctor. The doctor if the doctor believes that an MRI appointment is necessary, they will refer the patient via referral letters, whatever, to the hospital. And that hospital will further review this request. If hospital also finds it necessary, this request will be approved, and then patient can start to book an appointment on the time slot appropriate for them. Then patient needs to confirm before the appointment. Last but not least, patient makes it. So here's the whole workflow. I'm going to have a demo later, so just to make the presentation less boring, let's see. Before I show my demo, here are a few things I would like to let you know about technical background. What we did is we built an AI engine using LangChain to improve MRI scheduling. And LangChain is a company that provides the agent engineering platform, an open source framework developers need to ship great agents faster. And AI agent, when we are talking about AI agent nowadays, its architecture is introduced in 2023. The tools and the framework we're using to manage the memory, agent memory, and tools include fast MCP and so on and so forth. MCP stands for Model Context Protocol that standardizes how large language models should interact with tools deployed remotely. And we also use the containerization technology, Docker, yes. Methodology. Problem definition. So there are three main problems we can consider in this demo. The first problem is when some patient doesn't show up on time, the staff member has to either contact the following patients one by one through email or phone calls, or skip this appointment completely, which results in idle time. The second problem is when the patient attempts to book an appointment, they have to call the staff for empty slot. Like it will involve a lot of back and forth for sure. The last problem is the fact that someone might not even be comfortable to book appointments using phone calls. Our Agent AI solution comes in to automatically contact patients who book later on that day when someone reschedule or cancel their appointment, search the empty slot based on the given day and duration of exam, and manage the conversion between the table of referrals and schedule. Okay, here is the architectural overview of my demo. I mean, it's quite technical, but I will go over it very quick. First of all, can you see my cursor? Or is it too small? Anyway, so the orange box on the right-hand side is the agent, and we are using the OpenAI key. And the underlying model is GPT 5.5, I think it's the latest one. The AI agent will be connected with a MCP server, which manages all the tools. And in the middle, there's a middle layer called tool interceptor, which modifies the original MCP tool call request and modify the MCP tool results. And yeah, and also, agent's memory is enabled through using the Docker container of Postgres database. Yeah, this is the. Oh, by the way, there will be 3 processes involved in this demo. Actually, it's quite complicated, but so it's demo time. Let's go. Okay, so on the left-hand side, I'm not sure if you can see my demo. Sorry about it. So on the left-hand side is the existing schedule of appointments. There's a lot of columns. The first column is start time, second column is end time, then day, the month, the year, the exam time. the email of patient, because it's a demo, so I use my email, so the user ID and so on and so forth. And in the middle is the AI agent I will show later. On the right-hand side is a table of referrals, because most of the time, patient can only get one referral of MRI appointment, but some patients might have multiple referrals. Let's say this one, the first row is a referral referred by Tom, and the exam time is lag, the duration is 30 minutes. Okay, let's try something. Find the next empty slot with the minimal duration of 30 minutes. We'll just click it. The logic behind is it will search the empty slot after today, which is it will search the empty slot on June the 5th. So, oh, by the way, we also assume that the start of the operation hour is 8:30, by the way. Let's see what we can get. It might take some time, sorry. Okay, okay, this AI agent told me that the next available empty slot is on June the 5th, starting from 9:30. Yeah.
Keep quiet. It's fine. No problem. It's kind of going in and out of it.
Okay, thank you. Is that clear?
You can hold your laptop up.
It's displaying now.
Okay, thank you. So this AI agent successfully finds the empty slot. Okay, let's try to book it. Okay.
Is it possible just to tell us what you're seeing and we'll have to imagine it?
Give me a second.
Okay, we can see it now.
Is it?
You can see it now, yeah. I think you just keep on going. There's a problem with your connector, right? So it's going in and out. It's been going in and out the whole time. So just continue with the main points you want to convey.
Okay.
About 5 minutes.
Referred by Tom.
I think it's a connector. Yeah. Looks like an open. Yeah. Haley, are you able to just tell us what your?
So what?
I mean, it's just going in and out. We have about 5 minutes left.
I will try.
You can just tell us. We can imagine it.
No, I think they can't imagine it.
Okay, we can see it now. Go ahead, go fast.
I'm trying.
This was my experience when AI in healthcare was new, and doctors, clinicians started getting interested in AI in health. We give presentations of this type, and then like the PowerPoint wouldn't go on or the video wouldn't play, and we're trying to convince these people that technology is going to solve their problems. It was a bit of a hard sell. This is a bit atypical, though. We have about 3 minutes for questions. Yulin, I think we have like 3 minutes for questions. You presented a lot already. Is it okay if we go to the question period now? It's a hard stop in 3 minutes.
Can you see the screen now?
Yep.
Can you see the screen now? One of the referral on the right-hand side has been converted to an actual appointment at the left-hand side. So, okay, there are time limit. I have to finish this demo, and let's get back to the. Okay, you might notice that we didn't evaluate. We didn't compare our agentic AI solution with the existing approach in the hospital. Therefore, the evaluation will be done in the future. So in the future, we are going to consider to use the 3D simulation to simulate how hospital will look like given an appointment scheduling strategy. And under the leadership of Michael Zhang, an XR lab is built in SMIL. Therefore, we can dive into it and see whether our agentic AI solution is better. Thank you so much.
That was a great talk amongst all the. We have time for maybe one question. Yep.
Is your future work including something like a hologram?
Sorry, can you speak loudly?
I said that is the future work that you showed, is it something like a hologram? That's very interesting.
The reason why the future work is called future work is because it's not done yet. But when we are done, we will let you know. And yeah.
Thank you.
Yeah, thanks a lot. Thanks again. Let's thank our speaker. So next up is going to be Richard Levesque. He's currently serves as Director of Health Analytics and Predictive Intelligence at Vitalité Health Network, where he leads a multidisciplinary team delivering advanced analytics, artificial intelligence, and data-driven solutions to support healthcare decision-making. And are you plugged in?
There's one here.
Good.
Can you hear me well? I assume you're seeing the screen? Okay, that's good.
Sorry, are you okay?
I promise I won't do a demo because demo never work, right?
Oh, it's okay.
And so anyway, I'll get started right there. A couple of slides for you.
No, it was like
I try to
crazy.
keep it fairly simple. It's again, it's not a demo. We're not going to talk about models, stuff like that. But if you have questions after, of course, come see me. That's what we like. We like to talk about models, data, and stuff like that. So my name is Rick. I'm Director of Health Analytics at Vitalité Health Network. Today, I'd like to share how we are applying machine learning and AI to one of healthcare's most persistent challenge, which is patient flow. Obviously, as you know, hospitals are facing increasing demand, limited bed capacity, staffing pressures, rising operational costs. And at the same time, clinicians and operational leaders are expected to make what I would say increasingly complex decisions and capacity decisions, but with complete information, because we have lots of legacy system. So our objective here is simple, is to use AI to improve visibility across the patient journey, predict discharge earlier and more accurately, and help hospitals move the right patients to the right bed at the right time. It's important to start with the context. Very often I see presentations and there's no mentions of the pain points. In our case, obviously, in the hospital system, there's lots of pain points, lots of stuff that doesn't work. There's a first layer of problems that is at the structural level. So what's happening right now is kind of a tidal wave of individuals that are hitting the system. In the next 20, 25 years, I believe that the forecasts are that probably up to 250,000 individuals will come to New Brunswick. For a network like Vitalité, it means essentially that in the next 20, 25 years, we'll need probably 150 beds, something like that, which is hard, right? So it may not happen, so we need to optimize the system, the throughput, and optimize our length of stay, the way we deal with the patients. One thing with this item is that right now we're in high occupancy. Most of our units in our regional hospitals are like running at 120, 125%. We have more patients than beds. We don't know what to do with it, but this is what's happening right now. A second level of pain point is really about the operational level. At the same time as we're hit by increasing demand, and I forgot to mention aging as well, because we have more old folks that have more complicated case mix, and all that complexity needs to be dealt with, and it creates problem. The second layer is the operational level. At the same time as we have a tidal wave of individuals hitting the system, we also have an HR crunch. So it's very hard to hire people, especially specialists. Everything is actually difficult, from nurses to specialists to any other support staff. At the same time, we've got a hard time hiring people. It's very difficult. We have some success, but they're still missing some people. So there's an HR crunch at the same time. That creates disruption. That creates like a bit of difficulty in transitioning our patient. I think we're good, but in the future, it might become quite a problem. So that creates bottlenecks all over the place within the system. One of the most important layer for us in terms of pain point is, obviously for a data scientist, is the question of the decision-making level. So we have lots of legacy system. We have an old Meditech system. The data is all over the place. It's proprietary. It's sitting on different servers, that kind of thing. It's difficult. We can still extract the data, but it's difficult. So that creates problem in terms of bringing all the information in front, for example, of a patient flow team. Where do they get that information all in one place to make decisions? One of the difficulty, and that's basically at the inception of this project, is the question of how do we deal with estimated date of discharge. So there's a process to, at the inception or when the patient is admitted, to look at the diagnosis, have some sort of estimation of a length of stay, and then, of course, things change during the stay. So, but it's kind of imperfect. So we're still struggling with that aspect. How do we really have a good handle of what's happening with the patient, especially at the admission? What is the solution? Again, just a couple of slides there. Well, there's many different solutions. It could be continuous improvement. It could be a whiteboard. It could be all kinds of things. Of course, I'm director of analytics, so I really like data and models and stuff like that. The approach here was to create a unified patient flow optimization platform. We call it Optima for now. That could change name, but there's an application side to it. There's a applied research side to it as well. So we work with the University of Moncton on this collaboratively to build the back-end models to feed into Optima, right? And we developed the code for the front end, which is the application. The first component that we had, obviously, is data integration. So we bring together now, imperfectly, but we do our best there, information from bed roster. So who's in the bed right now, in what unit, what service, and we bring some socio-demographic information as well. A couple of things there that can help us to manage, each patient and a bed roster by hospital. We bring other data from an operational system like order entry, for example. What is the lab test that is asked, requested for a specific patient? Is there a rehab requested? Is there like an imaging requested? That kind of thing. We bring like clinical events from a service, when the patient goes from ICU to another service and so on. That information is brought in real time. So, and of course, the diagnosis portion that we, of course, enhance also with AI. So it's a real-time feeding. The second component that we, and it's conceptual and it's being done right now is, well, how do we make sense of all that data? 25 years ago, you could run, let's say, a hazard model on the data in Stata or SAS, and probably done that before during my PhD as well, and then that's it, just do a research piece. Here, the interesting part is that because of real advance, in AI, machine learning, I like to say machine learning, but in terms of AI, the code is better. It's almost at this point a commodity. What matters is the research design behind it. So the code is there, it's complicated, but it's possible to do something with it if you get the right data and the right research design and the right pain point. In this case, what we're using machine learning for is to predict a likely diagnosis, and of course to estimate the length of stay may be better, to generate expected discharge dates, and to calculate an overall probability of discharge for each patient to be able to prioritize. The third component and the fourth components obviously are like about the longitudinal pathway. So the application and the way we present the data and the bottleneck identification allows everybody to look at where the patients are in their stay. Is there any bottleneck right now? And how can I optimize the discharge? All of that, importantly, I would say, is that we're not replacing clinical judgment in there. We're supporting the teams. Very important to say that. We're not prescriptive entirely. It's all up to clinicians to make decisions. But we're definitely augmenting the decision-making with continuously updating predictive insight. To give an example a bit of what it looks like, I guess I like graphics in that case, but essentially you have a patient that comes in the system at day 0, and then you have Optima, all the models. All the information is coming in the system, and as new information becomes available, lab results, imaging results, and so on, and nurses' notes, because there's manual input in there, the system continuously updates the understanding of the patient. So in this case, we have a patient at day 0. I'm not going to go through the whole thing, but the gist of it is the patient comes, there's an estimation. In this case, it was like probably 5 days. Then they start doing stuff for the patient, lab test, and there's an imaging here that is requested. Second day, oh, interesting, I just knocked off 1 day, obviously. I've been there. And the system still says 5 days. But the results are coming and say, well, actually, it was not diagnosis X, that's diagnosis Y. Okay, interesting. There's no pending labs anymore. There's no pending imaging. There's no bottlenecks. And then notes are being entered in the system that are taken into account. So after 2 days, Optima comes back and based on AI again says, well, that person is probably good to go next day. 89% discharge ready at this point, and the diagnosis is different a little bit. So in one day, you can prepare that patients for discharge. That's the gist of it. And then obviously what the system does is to be able to put these patients in buckets. So I've got, let's say, 20% in the bucket fully ready for discharge. Maybe there's got 50% that are still not ready. They could be acute, they could be ALC patients, a long-term patient, because we do the both in there. That's the gist of it. The benefits, but overall, obviously, what we do that for also for the whole healthcare system, right? So the value at this point, and we're in a pilot now, we'll have better information about the impact, but the overall impact is essentially that we want to knock probably half a day or a full day of length of stay overall. So we're going to improve operational efficiency. Second, we want to improve operational effectiveness, so efficiency, and then the throughput through the system. So we want to be able to get them out quickly and get some more patients, again, in the system, increase the throughput, because, again, we want to save beds in the future. We probably cannot involve like investment for 150 beds because it's extremely expensive. So throughput, and of course, on the overall, optimize the capacity management, and finally, the insights that is generated by the platform supports continuous quality improvement, because it becomes a focal point where everybody sort of coordinate and talk about the patients and so on, and find solution, because that has to become at the local level. They are clinicians. Based on this, they can actually find new solutions to move the patients along in the system. So hopefully it's going to bring some efficiency in the whole healthcare. Maybe I have a minute or two? 4 minutes. Oh, 4 minutes, that's amazing. Well, I'll take 2 minutes. I know people like models, but me too, but I didn't want to get into the nitty-gritty of this, but I have to talk about it a little bit. I was talking about diagnosis, and the first part of it essentially is we've got some free text diagnosis, and of course after there's some stuff that's entered in the system. There's also like diagnoses that are on a sheet of paper still in the system. That's how it works. But what we've done working with the University of Moncton, and there's many different, if you want to talk with us after, and I know Louis Roldan is here as well in the third row. He was very, he was an important part of that project as well. If you want to talk about models, we can talk about Bert, Dr. Bert, and all that stuff, essentially NLP models. But University of Moncton really helped us with that, which is, we train on about 65,000 patients, if I remember, and to take that free text, go retrospectively, see what are the higher level attributes. So I've got like thousands of free texts, and I want to turn that into, give me like a 20 features for diagnosis. And in that case, it could be like major complication, that kind of thing. It could be different diagnosis grouping, but we use AI to do that, in that case, NLP. The third part, obviously, is the stuff that you're probably more familiar with it in healthcare. So we have a hazard survival framework that we solve with different things. Sometimes it's ML. We're trying to use temporal fusion transformers that will really look at the transition by patient day and eventually by real time. So of course, transformer is a little bit different. The data needs are different as well, but we're kind of testing both approaches to do a couple of things. First, calculate the probability of discharge in real time. Right now, what's my probability? Transform that into a score between 400 and 1,000. Are you fully ready? Not ready at all, that kind of thing. And also have better estimation based on all those attributes for each patient about what's my ELOS, what's my expected length of stay, what is my expected date of discharge. They're both the same thing, right? So that's technical, but that's working so far. We've done a lot of tests. I think the future is probably towards a mix of both, transformers, probably NXG boost, usual machine learning. And that's probably what's going to happen. We're segregating acute and ALC now, 1 minute. Very important, maybe that's one thing that I believe it's important to mention. In terms of probability, an acute patient is very different than a long-term patient. So you can start acute. In the first 2-3 weeks, you arrive at the hospital, your probability of discharge is going to increase. Slow day is going to increase. After 2-3 weeks, if you're not out, it started decreasing. So it's mathematical. It's mathematical. If you look at all the data, and we have like 800,000 rows of patient days in there, it's mathematical. So if you're stuck, you're stuck. Then you might turn ALC, and your probability of discharge can come all the way down to 1% at some point. So we segregate the models in that case just to make sure we optimize, the value of the data using machine learning. The last component, I'm going to finish with that, is that after doing all that, and there's also manual data input, I would say, in the app, so they can write notes, they can change the diagnosis, all that stuff is good. We take all that stuff and using Gen AI, and I'm not going to mention the model we're using right now because it's a pretty rudimentary model for testing, but we take all that stuff and we generate like a summary, essentially looking at all the system data, all the manual data. I'm looking at Richard and say like, what are the roadblocks? What's the probability? What is recommended that you do to move that patient along? And we're testing that right now. That's pretty much the talk at this point. I'll leave it at that. Thank you.
Thank you very much. So I'm going to apologize for stepping on questions. We have a session right after us, so we don't want to step on their time. So we're going to thank the speaker and get the next one on. I think you invited us to ask you questions anyway, right? So
You can talk to me
afterwards, yeah.
Thank you very much.
Thanks so much. So our third speaker, Ron Parker. Ron has over 40 years of experience as a consultant in IT solutions for public sector health and social services enterprises. In his 15 years with Canada Health Infoway, he was the lead architect and accountable director for the Canadian Electronic Health Record Systems Blueprint. He was also the lead for the National Health Standards Needs Analysis that resulted in the Pan-Canadian Health Informatics Standards Collaborative. And we can see it.
I just got to put it into presentation mode. Hello, everybody. It's amazing. Over there, can't hear. Here, I hope you can hear. So we'll carry on. All right, one moment. I'll just get myself in slideshow mode, and we'll begin. Okay. So this is really, I've been using AI for a while. Using it with clients, using it personally, enjoying it for the most part, entertained often. But I want to tell you some stories about things that I'm very concerned about, given my history, long history, 40 years doing social services and healthcare systems, in terms of things that have been neglected in the past, and the consequences of neglecting them going into the future with AI are even more profound. So we'll walk through this now. So the following is a true story. It's January 2023 in a boardroom at a Ministry of Health. And the mission to be in that room is to develop a digital health architectural blueprint for an island nation of 21 million people. Now, I'll pause here. Much of the work has been done at this point in terms of describing that documentation, putting it together, describing all of the things that need to be true in order to be able to execute it. And just as we're going through that part of the day, the client lead puts ChatGPT 3.5 up on the boardroom screen. And it's just come out in November. Nobody's really using it very actively. And this is his prompt. What are the necessary components of a digital health enterprise architecture? Now, we've pretty much already written this stuff, right? Like, we think we're almost done. And I'm thinking, okay. And he hits enter, and suddenly the screen starts scrolling, and I have to tell you, this was my response. Oh, crap. What is going to happen here? Am I going to look like a complete idiot? Is my team going to look crazy? Like, what is going to happen here? And we're watching, and, and it finally it stops scrolling, and we go back through some of the stuff, and it was like, wait a minute, I think we're fine. Yay! And then he turns and he looks at us in the room, and this is exactly his gesture. He didn't say a thing. He just went like this. He looks up at what's up at the screen. He looks at us and he goes, and right away, the thought bubble over his head I'm imagining is, do I really need these guys? I think I can do this myself. That was my big wake-up moment, that I really had to start engaging with AI. So just a little anecdote. Now we'll start with a problem statement, okay? The problem statement is basically this. There is a truism that change is the only constant. It is a constant thing. Things are constantly changing, and the rate at which they're changing now is staggering. But there is another constant, and that's humans. And I am a keen studier of human nature and of how people do things and why they choose to do what they do and how they behave, how they respond to things that impact them. And one of the things I can tell you in my history is that not engaging with those affected by IT that is being implemented is not good. You can spend millions of dollars, do a great job, your coding could be perfect. But if you have not engaged with people from the very, very outset in terms of, does this match their expectations? Do they understand the potential impact to them in the implementation of this system? It's not going to go well. And by the way, that's a conventional view of things. AI and the potential of it, the capacity of it to either do really, really good for you or really go off the ranch is extremely high, and especially if you don't engage with people. And I worry about this a great deal because trust is such an essential function of being able to do this. We cannot lose trust. We have to build trust and we have to obtain it. So on that note, here's what we're going to explore this afternoon. So the psychology of technology acceptance. There is a technology acceptance framework. We'll go look at that. How humans calibrate trust with AI. Very interesting. It's not that much different than getting a new person on your team in a time crunch and knowing they have to be delegated work and it's going to affect you if it doesn't happen. It's not that dissimilar, actually, in terms of the things that you need to be able to do to have confidence. And barriers to AI adoption, some biases in ethics and institutional resistance, societal and ethical implications, pathways to acceptance. So I'm going to propose, or rather the presentation proposes this, and the role of AI in interoperability. And it's just a focus of mine because I'm also not only involved in architecture, but I'm very, very deeply engaged in the standards that allow information to flow between systems. All right, so here's the technology model. This is a basic foundational model for why people adopt or reject new technology. So there's external variables like what's the design like, what's the training, organizational factors. Is it useful? Like, will it be useful? That just the perception of that, not the fact of it even, just the perception. What is the ease of use? What is the attitude toward the use? In other words, are there positive or negative feelings about AI? And just ask me that day when that guy put that up on the screen, and my feelings about AI were not great. And then actual system use. What is the real world adoption behavior look like? And I just want to pause there because I want to also emphasize for people, my great learning in life is that people don't react or don't change behavior based upon logic. They do it based upon emotion. And if you don't emotionally engage with people and understand what matters to them, what their fears and anxieties are, they will not change their behavior no matter what you try and insist they do. Now, key psychological factors in AI acceptance: anxiety and fear, technophobia, job displacement concerns, that was what I was worried about that day, and a reduced willingness to adopt. Self-efficacy, confidence in one's ability to use AI systems actually drives up adoption, not just by you, but the people who know you and know that this is what you're doing. Social influence, peer norms and authority figures shape AI acceptance behavior hugely. So if you're trying to do AI inside an organization where, for example, a CEO or senior executives are meh, you've got a problem. They really need to champion for you. And then finally, the idea of cognitive load. Complex interfaces increase resistance and perceived effort. So the cognitive burden, even just thinking about making this leap, can be pretty severe. Now, this is a really interesting diagram. It's a trust calibration spectrum. At the far right in red, you've got no trust, distrust, skepticism, okay, I'm feeling neutral. Oh, I have a reliance on this now. Like if it goes away, I'll be upset, and overtrust. And the optimal zone, as you see, there's that little line at the bottom, calibrated trust with appropriate skepticism. And I strongly, strongly encourage appropriate skepticism. One of the best ways you can test your AI, particularly if you're using generative AI and doing exercises with that, is ask questions about something that you know the answer to and see how it correlates. And I had this problem very recently. I asked a question, I knew what the answer was, and it was like, the answer it gave me was like, nah, not a problem. I was like, okay, please go look at this chapter in this text, and this was doing stuff around, by the way, the World Trade Organization. And why do we have standards development organizations? This is the thing I'm in. And it turns out there's a section in there called barriers to trade. So if you're a signatory, and there are 138 countries who are signatories to the World Trade Organization, you have to adhere to this, which means you have to agree that you will not create proprietary standards that are going to prohibit trade from existing between these countries. And every country has a mechanism that enforces them. Anyway, so that's a sidetrack. So what I did is I essentially told it, go look at that book, look at section 4, and read this piece. At which point the answer completely changed. And the AI responded very productively to it. So I really recommend you do this. The interesting thing about that is it actually made me a lot more comfortable in the fact that actually I can interact with these things and test. I can have greater confidence because I can be able to do that, and it has no emotion about it whatsoever. I can challenge it, and I can learn things, and I can learn how to work with it better. Now, here's some of the things in terms of gaining AI trust. Transparency, explainable AI decisions build user confidence. You have to be able to explain how it came to that conclusion. Reliability, is the performance consistent across contexts? Security, do we have data protection? Do we have creates institutional trust? And human oversight. So we need to know that there's a hybrid human AI model that will preserve trust. To try and work, especially at this stage in our processes, to put AI out there as really autonomous without that regulator is a very risky thing to do at this stage in our evolution. Now, why will healthcare professionals, and forgive me, I am in the healthcare field, so this is the area that I have the greatest comfort in, so this is why we're focusing. Psychological barriers. Fear of de-skilling and job replacement. Number one with the bullet. Comment. In the early days of AI, or not of AI, but of IT systems, it was often the people who were at administrative levels or doing very repetitive things that were worried that the technology was going to make them irrelevant. In the era of AI, that has flipped, and now it's the decision makers that are becoming very concerned about their value proposition when AI has this massive ability to look through the LLMs and have these very definitive expressions. It's just something to think about. Loss of clinical autonomy, particularly for clinicians. They're deeply independent people. They're competitive. They're taught to be the best they can possibly be. And to lose their autonomy in terms of the way that they do things, there's a science to healthcare, and there's also an art to healthcare. And most practitioners have their own particular way of doing these things. So they want to preserve autonomy. Imposter syndrome with AI assistance. That's an interesting nuance. And then an overconfidence bias in AI outputs. And this is the thing, man, like every time I talk to anybody about this, in all the things that I do, never, never, never trust the first cut, right? Ask the question, ask it a different way, ask it a different way again. And gradually you will drift into where you probably need to be. Institutional barriers, of course, are lack of AI training and medical education. And I want to talk about this later, especially, because it's not just the clinicians, but nursing, you name it. And not only that, by the way, administration, because administration stands to benefit a great deal from use of AI. But they need to be trained. They need to be comfortable. Regulatory uncertainty and liability fears. So here's the other thing that we need to consider. In healthcare, amongst the disciplines, the many disciplines that make healthcare go, there are belief systems around what you can and cannot do that are sometimes mythical. They're not really real. It's just people have come to believe this over time. Got great stories about that. So you have to be very, very certain that you're in the right space. Siloed EHR systems and data fragmentation, of course, is a huge problem. Absolutely huge problem. This has been my life for the last 25 years. And resistance from professional bodies. This goes back to the other things. Little anecdote, I know of a CIO who was having issues with an EHR implementation. Back to this issue of uncertainty and what liability was. He went to each of the departments and they said, well, no, sorry, we can't do that. And we're not allowed to do this and we're not allowed to do that. And he did that for every single discipline in the hospital. Then he went and talked to their respective colleges, those that are set their standards for professional practice. And then what he did is when he had finished all of that, he put out a notice for a meeting in the amphitheater and he said, hey, would you like to hear what your professional discipline says about those questions I was asking you? And he asked all these questions within each discipline in an isolated way, but he brought them all into the room. The response was so overwhelming, they were worried the fire department would cite them for a violation. The CEO was in the room, turned around at the front of the room, turned around at one point and looked at standing room only. He says, who is running this hospital? What happened when he went through all of this process? He said, nope, sorry, myth. Here's the thing you told me. That's a myth. No, that one's pretty good. That's good. He went through and he went through it for all of the disciplines. And when he was done, a remarkable thing happened. Their self-awareness or their mutual awareness of what their concerns were and the angst were worked out, and it was evenly distributed across all of them. Nobody was called out. Nobody was put in a particularly difficult position. It was very, very powerful. So again, very important to reduce resistance from professional bodies by doing this. Patient distrust of algorithmic decisions, that's another social cultural barrier. Health equity concerns in AI data sets, that's profound. Like if the data you're consuming is unbalanced, then you have a real risk of further exacerbating that problem in terms of bias. Language and cultural bias, yes, and generational differences in tech adoption. So this is very interesting. Thank you. I'll go through this real quick. What the research tells us, 76% of patients are open to AI-assisted diagnosis if explained by a clinician. 45% of radiologists report feeling threatened by AI adoption in diagnostic imaging. 3.2 times higher adoption rates when staff receive AI training versus no training. And 62% of healthcare AI failures are traced to poor human interface design. Patient openness to AI diagnosis by age groups, notice this. Age 18 to 34, trust is 70%, 72%. And when we get to 75, it erodes down to 31%. Important to know. So from an ethical perspective, there are algorithmic biases and health inequity in terms of the data, as I just pointed out. Privacy versus data utility. Now, it's good to have lots of data to be able to effectively treat a patient, but you have to be careful about how that works from a consent perspective. And so one of the things we try to do in healthcare is look very closely at the boundary between when we need unidentified or pseudonymized data and when we need the actual data, and keep those two things separate. Accountability gaps. Now here's the interesting thing, and this does worry me about AI. When you're using AI at this level, who's responsible for solving the problems? People often, by the way, will want to blame somebody, but who the heck are they going to do that? And there's all kinds of legal and ethical vacuums this creates. And there's erosion of therapeutic alliance, meaning that bond between the care provider and the patient. If AI is intermediating excessively, where they don't have that relationship without transparency, it upsets them. So here's some things in terms of guiding ethical frameworks: principlism, principles-based, preserving relational aspects of medicine, care ethics, consequentialist consequentialist AI governance, outcomes over intentions. In other words, focus on the outcomes. You need to be going there. And also deontological constraints, rights-based data protection. You have to protect that as well. And rolling right along. So now pathways to a possible acceptance. So we're concerned. I have a concern. How do we solve for this? Co-design with clinicians. Work with them in terms of the work that you do. Explainable AI. Be able to explain. Don't do black box. Graduated exposure. Implement it incrementally. Targeted education. Equitable data governance. And clear accountability frameworks. Now, in terms of the interoperability challenge, I'll just take a moment on this. Some people assume that AI will just solve the problem of the data hanging together and they'll just do it on the fly. Really not a good idea. One of the first questions I asked AI when I got that is there still inherent value of codifying information and having disciplines standardize on their representation of things to achieve what you need to achieve as an AI? And the answer was absolutely yes. You're going to burn so many cycles trying to do it the other way. And then also around procedural workflows, there's a lot of value, I believe, there, but you have to be careful because you really need to recognize the human dynamic when you're doing anything in the workflow space. I'm just going to skip this one. This is sort of where things are going. And so here we are, key takeaways. AI acceptance in healthcare is fundamentally a human problem. You must earn it. Transparency, reliability, genuine co-design. Psychological barriers, address those. Health equity requires that AI systems are audited continuously for bias. And here's my question, how will this be done and who will do it? This is a new role, okay? This is a new role. And finally, the therapeutic relationship between patient and clinician must remain central. And the most transformative AI systems will be those that enhance, not replace, human judgment and compassion. That's it. Questions?
I don't think we have time for questions, unfortunately.
Oh, no.
I'll
hang around.
Unless can audience members track you down and ask you.
Sure, absolutely. I'll hang around here for a while.
And if the next speakers aren't here, maybe we do have time.
All right. Thank you.
We have Arslan and Peter from Deloitte. Great. Okay. Are you going to get set up? Okay. I'm going to just introduce you guys. Do you have a laptop or something? Or? The same one? Okay, great. Okay, perfect. So our next speakers, Arslan Idris is a partner in Deloitte Digital and leads Deloitte Canada's Life Sciences and Aging Well sector, focused on digital citizens transformation initiatives with emphasis on digital health, consumer health, AI, and health innovation. And Dr. Peter Back is the Chief Information Officer at Humber River Health, where he leads the digital vision, enterprise technology operations, and innovation agenda. He is currently focused on scaling the responsible adoption of generative AI and expanding citizen development across the organization. You have 17 minutes.
Well, that was a mouthful. Boy.
There's a lot of, I had to pair it.
Okay. All these guys are telling you lots of good stuff. I'm, at the end of the day, at the front end trying to deliver this stuff. Let me start by asking, 2 years ago, who was using AI, ChatGPT, and embarrassed to tell people about that? Hands up. Come on, you're lying. Okay, today, if you're not using AI, are you embarrassed about that? Yes. So this is the issue. This technology is incredibly powerful. So we're all talking about adoption and all this kind of stuff, but in my career, which I'm a little gray hair, same like Ron, we've seen many technology revolutions. This one, the biggest ever in my entire life, it is changing our world. So the challenge here is not about getting people to use it because they are. Whether you tell them to stop or not, they will use it, and they are. The challenge is this stuff is seriously risky at the front line. And what I want to talk about is, I'm going to make a provocative statement here, which is we cannot use AI, generative AI today, for any clinical decision work, end of story, until we fix the trust problem. Let me tell you a story about this, because some of you will shake your head and go, huh? We were looking at, I was going, bring it on, guys. Let's roll this out. This is going to transform our operation. Let's have AI everywhere. And we have a solution that has a chatbot sitting on our policy documents. And our risk officer, I said, turn it on. This is going to be great. And the risk officer went, no way. No, you can't do that. I want to test this. And so she sat there trying to brute force test whether this AI was going to be accurate every single time. And I looked at her and I went, what are you doing? This is impossible. You can't do that. And it hit me right there that one of the problems that we have is that we live in a world of probabilistic inference with deterministic expectation. Fancy phrase, but stick with it, because this is the fundamental issue we have. AI is going to give you an output. That output is probabilistic. It's not the same output every single time. Ron made a statement, well, you better ask it 6 times over and then see what you get. That isn't practical. So you're going to get an output, but when shit hits the fan, we all go back to evidence. We all go back to, on what grounds did you make the decision? And you don't have that anymore. I can log whatever it said, but I have no evidence of how it came to the outcome that it gave me, and on what grounds did I make the decision. This is the challenge. And let me just read this stuff. So where we sit is right now, we have lots of AI tools that are being presented to us, and everybody is delegating liability to me. And they start off by going, oh, the doc, you hold responsibility. And the doc goes, not mine, because you're the CIO, you gave me the tool, hospital owns the liability. This is fairly normal. This happens in all of our systems. In this particular case, I'm taking liability for ensuring that the physician who uses the AI checks that the output is good. And that is human in the loop, which will not work at scale. It works in certain circumstances, but when this goes at scale, it will not work. So, the world that we're living in right now is one where, yes, AI is incredible, and we take it almost for granted that when it gives me an answer, it's going to be great and I'll use it. That is very dangerous when we are making clinical decisions or impacting something to do with the patient. So here's an example of what is beginning to happen. The answer to this problem is governance. Great. And we'll put frameworks in place, and we'll do risk assessment, and then we'll do monitoring, and we'll do all those things. And I'm looking at all of this. And by the way, we have to do this. This is the right thing to do, but it doesn't solve the problem. And here is a perfect example. In Ontario, we are using AI Scribe quite extensively in many hospitals now. At our hospital, we did the same. And we're relying entirely on human in the loop. So if you're familiar with this, you're sitting with the patient, it automatically transcribes the notes. The doc is supposed to read it, and in our case, it's not integrated with our EMR, so you have to cut and paste the result into the EMR. So you're forced to have to read it and say, is this okay? And I thought, and I'll say I, because at the end of the day, I'm the CIO responsible for this. I said, okay, well, that's a pretty safe way to go, minimize the risk. The Ontario Auditor General went out and did an assessment of all of this and came back and said, not good enough. So what you see on the screen here are some of the results, and they're basically saying, as the regulator now, that model of human in the loop, even when it appears to be okay, is not good enough. But what's happening here is that governance models are not cutting it. And we're spending all of our energy on making those governance models better, but they won't cut it at the end of the day. So, and here's what you see with governance models. And I wrote up, we created a framework, and we used NIST and PwC and everybody's, all these good practice, best practices. And I wrote this thing up, and we have this risk assessment that says, great, I'm going to grade this AI application by use case and see how risky it is. If it's sort of not too risky, we'll use it, but then we'll have all these safeguards. So look at what it says for safeguards. I'm going to measure the data that the model was trained on, and then I'm going to check for bias, and I'm going to track drift. And I'm sitting there going, how the hell am I going to do this? I'm using Bedrock from AWS. So what, I'm going to call AWS, hey guys, what data did you use? They're going to tell me to F off. So it's like, that ain't happening. So these safeguards are impractical. And this is the challenge that we face. So how are we going to solve this problem? At the end of the day, what we really need is some mechanism by which, at the time that I get an output from an inference engine, I get something that tells me, can I use it? And I want to make the point here that this is not about, is it accurate? No, humans will make judgments. That's our business, especially in medicine. We make judgments all the time. But what I need to know is, what I got, was it good enough for me to make a call and make my decision? And you might wonder, well, how the heck do we do that? It's possible. I won't dig into the how, but it's possible. And the second thing that I need is a record of that decision, so that when I'm in a court case later on and they're saying, what happened? How did you make that decision? I can defend myself. This is what is really a foundational piece required, not only in healthcare, but in any governed environment where we're using outputs from probabilistic systems, and we need deterministic evidence for what decision we made. I believe that when this problem is cracked, the ability for us to use Gen AI broadly in a riskier environment suddenly becomes possible. And until this is cracked, all this governance framework stuff just ain't going to cut it. And we're going to see one fatal accident, and the door will shut on all of us in using this stuff until we solve this problem. And so, on that note, I'll ask Aslan to tell you about a solution that we have.
Awesome. Before I talk about the solution itself, you remember Peter talked about that the chief privacy officer that was trying to break the system? It's before he met me, because after he met me, we solved the problem itself. I want to quickly talk about Helix, and this is a platform that is incubated out of Humber, and now we're scaling it as a platform. But take a step back and think about Helix is all about solving stupidly simple things, leveraging AI at its core. And privacy, security, compliance is everything that we are doing. But the idea is starting off that we can build these stupidly simple things. Then you walk into the hospital or you think something is not connected. We're building these apps, deploying it, and eventually the clinicians can build it, because the trust factor will always be baked in the baseline in itself. I want to actually get your eyes on this slide a little bit, that when we look at the trust, which is not just isn't about policy. Policy Engine is one of the flagship applications within Helix. Think about if you want to query your hospital policies, whether it's clinical guideline, procedures, and just normal IT policies. It is context aware, so it actually, you can query based on your role. It automatically knows and it references based on that. And it will point you to the right document as well. So reliability scoring is there. The uncertainty and bias we're taking care of. Human in the loop, Peter talked about, is by default is everything we're doing in Helix. And there is an audit trail. And what I want to ask a question on the right side, from the techies in the room, if I turn around and say, there's 92% accuracy for answering the question that's on the screen, which is what protocol for managing patients who are suspected for sepsis. For those clinicians in the room, imagine you see 92% accuracy score. Are you going to trust? So the part of the puzzle that we're also solving with Helix is not just about reliability, calculating the score, but it's actually the experience on when that score gets displayed and who it gets displayed and how we use it. Because getting a 92 or 95% accuracy is extremely hard in some of this AI, Gen AI world that we're playing in. But displaying that to a nurse or a physician who's about to make a decision, maybe you will lose the confidence. So that's the framework that we're working on, making sure that the decisions are getting made, but the relevant information is getting shown to the people who are making the decision. And our vision is, in the months to come, we'll be actually rolling out these applications who are built on top of this platform, and the trust will be not something that you will be an afterthought. It'll be embedded into every part of the puzzle that we're trying to solve. So we went live with 2 hospitals in Ontario, and now we are in UAT stages with a couple of the other hospitals. I'll stop here if there's time for a couple of questions or no? Yeah.
Okay, great. Okay. Thanks so much.
Yeah.
Any questions?
Yeah. So the Policy Pal is one application. The other application is what we call is peer-to-peer app. So it's actually connecting current patients in the hospital that went through the, let's say, cancer treatment. It will connect to the peer patients that went through it in a secure way. They can chat. But think about it, in a week's time, there will be 1,000 messages that people were talking, and you don't have the time to go through that. So what the agent can do is it can summarize all the relevant information and give to the nurse the day that they want to look at. Another application is actually what we are building with Humber, deploying at Humber. It's called ALC, alternate level of care. So we're predicting patients before they become ALC patients, so their action can be taken as an example. And then there are simplest applications around scheduling, prediction models that we're also building on top as well. Yeah, good.
I'm going to leap forward to the future. Where we want to go is fully autonomous operations in the hospital using agentic AI. So now imagine that you have agents doing a whole pile of work. And I think there was somebody that was talking about this. But the idea is that I have agents that are automatically ordering, rebooking, rescheduling, potentially putting in orders for medicine and so on. How on earth are we ever going to do that if we don't have something that tells us the agent can do that safely and reliably? So what we're really pioneering here is this concept of confidence score and learning about those scores so that when you get to autonomous operation, you can actually put these scores in. And some of them will be empirical, by the way, because you've got to see, like Azim was saying, is 92 a good number? Should it be 95? That has to come with empirical knowledge. But eventually you get to a point where you say, that agent can take that action because what it got was a 92. If it was a 35, stop. Send up the alarms or do whatever. This is where this is going. And right now we're dealing with lots of individual use cases, but all to really work out how this works well to move to the world where agents take over from us.
We have time for one more question.
So part of the equation is whether the systems can reproduce or mimic human actors. Now, a lot of these machine learning models are better at getting correlations within data than we are. do we also get into like a risk where actually better treatments or better processes are going to be dismissed simply because a human is not willing to take that risk of a better, objectively better than, okay, decision there?
I think it's way too early to make a comment on that. I can imagine in the future that AI will make, well, let me answer it this way. Previous speaker was talking about length of stay and trying to predict and flow and stuff like that. Our hospital is one of the best flow hospitals in the world. And we're using what that guy's doing already for 7 years. And even though we have data telling us about insight, what actions to take and so on, humans are still foible. We still miss things. We still kind of go, oh, well, I'm a bit tired right now, so I won't do that. The beauty of agents, they don't tire. They don't make those mistakes. So will AI technology do things better than humans? Without a doubt. But that doesn't mean that they do everything better than humans. So there will be a place where we can delegate to agent technology to do it. And then there will be clearly places where you need the physicians. This is never going to be no humans in the building. Although I have seen in China the entire AI hospital. Not sure I want to go there, but I'm looking at your speech and the work that you do. That you will never replace.
That's amazing. Let's thank the speakers again.
Thank you very much.
So this is the last talk of the session. This is going to be Jen Woodland and Vince McMullen. Dr. Jen Woodland is an associate professor in the School of Integrated Health at the University of New Brunswick. She works at the intersection of mental health, healthcare systems, and implementation. And Vince McMullen is the founder of CanXP AI, a Canadian sovereign AI company focused on private AI infrastructure, model training, secure edge development, deployment, and AI governance for regulated organizations.
Oh.
I'll take a few seconds while we're getting set up I'll say what I was going to say at the end of the session because we have a session right after us. A few hours ago, the Prime Minister announced the new version of the Canadian AI strategy, and he did it in front of rows of doctors at UHN. And I think in addition to all of the specifics of the announcement, it was a pretty clear signal that the AI strategy in Canada is going to have a very high focus on healthcare because of how important it is. And I think already we've seen 4 great talks about some interesting work in this area, and I'm looking forward to seeing the discussion continue over the course of the next day and a half.
Is it up? Is it good? Are the slides up? Okay, great. Okay, perfect. Thank you very much. Hi, everyone. I'm Jen Woodland. I am an associate professor at UNB within the School of Integrated Health. And as mentioned, I'm here with my collaborator today and colleague, Vince McMullen, and we're going to tie a couple of things together here for you today. And listening to the talks within this session, I know that we're in great company. We're all speaking the same language, and we're all saying pretty much sort of the same things from time to time. So this is going to be a similar concept. And I just want to mention as well that, you know, the theme of this summit here, I think, I can't remember the exact theme, but it's something along the lines of acceleration and bringing AI to market and commercialization, et cetera, and use in a very fast way and accelerating that. And while that is incredibly important, what is also important, particularly within health and healthcare, is doing so not just at at speed, full steam ahead, but at the speed of trust and how we can trust systems in those integrations. So what we're going to do here today is I'm going to talk about the clinical side, clinical research specifically, and implementation science of bringing interventions that are AI enabled to life in real health systems. And then I'm going to hand it over to Vince, and he's going to bring in that AI and the high tech component to help us understand how we can really inform those interventions in a really meaningful and trusted way. And via CanXP AI, which is a sovereign infrastructure company as well. And that's something we hadn't really talked to until this point. At least I haven't heard anything else in the room around sovereign infrastructure, but that is incredibly important for health and for healthcare. So I want to begin here by discussing a couple of differences and one of the critical central tensions within AI in healthcare specifically. And that's that difference between what we can build and what we should build and what we can responsibly implement. So what we can build from the technical side and the prototype logic side are things like, does the model exist? Can we build the model? Does the model work? Is it effective? Is it efficient? And all of those questions, surrounding whether we have access to that, et cetera. And those are really foundational. But what also matters is what can we within healthcare and within these contexts responsibly implement. And that's where we come into the transfer between prototype logic and systems logic. So when I say system, I'm really referring to that healthcare system, and within that health research system especially. And so these are things that we have already heard today. So things like workflow. Can it work within an existing workflow? Or is it going to add more burden? Is it going to add more pressure to already pain points within the system? And, will it be adopted? And there's lots of social psychology, as we've learned today, surrounding why and when and where and how things will be or could be adopted within a particular setting. But then there's also the accountability on risk and sustainability along with that as well. And that's where Vince's work is really going to come into play here, particularly within that risk area and that trust area as well. And what I also heard today and what I'm going to talk a little bit about is that sustainability of interventions once they are implemented. So sustainability and implementation are critical and they're necessary, but what also comes along with that is that evaluation piece and that monitoring piece. And just as important as implementation strategy is that de-implementation strategy when something is going wrong or when it's not working the way we had originally anticipated. And so how I'm going to preface this before talking about the technology and the AI side of piece alongside Vince here is bring you up to date with two health use cases that I've been working through. So these are health use cases that I have either led or am a very big part of. And I'll begin here with cardiac rehabilitation. Now, if you don't know what cardiac rehabilitation is, they are programs that patients are referred to after you experience a cardiac event or have cardiac surgery. Now, they can exist in a different modality, so we can have them in person, cardiac rehabilitation in person. You go to offices, you do the physical exercises, et cetera. Or they could be virtual cardiac rehabilitation programs as well. And some of this work really stems upon the introduction of those interventions to enable patients to attend and to adapt to those cardiac rehabilitation programs. So within this body of research, and I have here some references on the bottom, the overall program of research is really contingent on an aging in place study. And more specifically, when individuals are at risk of not participating in cardiac rehabilitation programs that we know are going to be beneficial from them based on evidence, we want to get in there early and really assess and predict, is a word we've been hearing a lot, who is likely to not participate or who is at risk of non-participation. Because we want to capture them, we want to identify them early on so that we can then tailor an approach so that we would make them more likely to participate in the programs that will help them in the long run in terms of their health outcomes. Now, part of doing this is, of course, with data. And one of the main points of this program of research that really stood out to us in identifying those barriers is that we were able to identify barriers that exist beyond the traditional barriers of non-participation. So when I say traditional barriers, I mean, or typical barriers, rather, I should say. So things like transportation and cost and so on, getting to the place, getting there on time, actually doing the rehabilitation programs. And, but what we determined above and beyond that really is that things like mental health factors, such as depression and anxiety, are really contributing factors to people not participating in these programs. And so what we are hoping to do, and I have been working toward, is helping identify those people who are at risk of increased levels of depression or anxiety post-discharge from hospital, so that we can then tailor treatment and management plans and capture them and help them in the referral process thereafter. So that's one of those use cases that we can really integrate the benefits of AI and AI in healthcare into. So in this instance, prediction is important, but it's just the first point. Prediction and identifying someone who's at risk of something is the first step. The next step is that intervention and the implementation of that intervention. And so the second project here is really an example that's really close to my heart. And this is the program of research that I currently lead. And this is a database project, and it's called the Asthma Innovation Research Project, or AIR, I call it. And this project really stems from some work that I've done on COPD in the past in identifying individuals who weren't using their medications properly or weren't using their inhaled devices properly, or weren't sticking to that regimented plan as expected, and therefore they weren't improving. So we took this and expanded it and generalized that, the important pieces, to kids and kids living with asthma in our region. So currently this is implemented, it was implemented about a year ago at the St. John Regional Hospital within the Pediatric Asthma Clinic, along with Dr. Wendy Alexander. And from there, what we do is every kid that comes through the asthma clinic at the St. John Regional Hospital, we collect data with them. And I say with them because it's not entirely self-report. At this stage, it is a little bit facilitated because they're children and it's a vulnerable population. And so we collect information not only on the child, but also their parent and their home context, because all of this really helps inform that broader picture. And so now we have that really wide data set. And this is where the data and big data and the AI comes into play, is because we now have that really wide, comprehensive biopsychosocial database of information that we can then use to predict a variety of different research question outcomes. And so in this case, again, that data specifically is not the intervention, but how we're going to use that is the intervention, and how we use that, but more importantly, how we implement it within the context of that clinic. Because as we've heard throughout the afternoon, it's not easy to just deploy something and expect that it's going to work, or build something from an architectural point of view and expect it to work the way you want it to within a variety of different contexts. So we've been working with the patients and the parents in the clinic and the staff to ensure that we know right from the get-go, starting and building from the ground up, what's going to work within that context. And then we can build around that and apply those technical solutions and the models to help us identify and then escalate. When I say escalate, what I mean is it could be a variety of different things. It could be a referral pathway. It could be a follow-up appointment. Whatever that escalation path is, that's also a point where AI can help with that process as well, more efficiently and in a trusted way. And so, generally speaking, that's where we have to start with the foundation. So we have to have that strong foundation. And in this case, we really believe that that strong foundation is that sovereign technical infrastructure. So sovereign in this case, because we need to make sure that we are our own custodians of our own data, and we're the stewards of our own data, and that data is used as it is anticipated. So a lot of the solutions that we know of, including ChatGPT and Anthropic and Gemini, et cetera, they're reliant on systems outside of Canada. And that's okay, and that's the norm, but it's not really okay within the healthcare system. And that's where the biggest difference lies, because we have lots of regulation surrounding PHI that really needs a stronger and Canadian-owned solution. So we start with that layer, we start with the infrastructure layer, and then work upward to the governance and accountability. And that includes things like the privacy, consent of patients, and so on, and that escalation path that I've referred to. Once that is done, then we can move forward to evaluation and evidence. So evaluation of those systems that are implemented is absolutely critical, because as mentioned, when something's not working, or maybe it's causing harm, and I don't mean physical harm in its entirety, it could also be harm in terms of adding burden to an already, strapped system. So we need to have that de-implementation plan as well. And then finally, working up through to that human-centered adoption. And I'm not going to go into too much more detail about this because we've heard a lot about it today. And I'm really glad that we did, because I know that people in the room are talking about, those human factors and how we're interacting with systems and what is that social psychology behind that behavior. And so that's really where that trust piece comes from. It's where the confidence, not only from the clinician, but the patient comes from. And the AI within these systems can really embed and just accelerate that trust. And this is where I'm going to hand it over to Vince here, and he's going to help us understand more accurately where that trust in terms of the infrastructure layer and the systems can come into play.
All right, the moderator says I got 3 minutes, so I'll make this quick. Dr. Woodland, thank you very much. My company is working on developing implementation infrastructure. So she's been talking about implementation science to this point, and she's done a really great job walking us through the point of now we need to talk about the infrastructure. Sovereignty. So when we talk about sovereignty, we usually think about in terms of political boundaries, but in terms of sovereignty, we also need to think about sovereignty in terms of the people, the jurisdictions, the places where these health authorities exist, and how we go ahead and implement that science in terms of the infrastructure. Oftentimes in AI, we're talking about prediction, but interestingly enough, prediction is just 1 second here. Interestingly enough, predictions is something that we need to think about the patient's outcome after the prediction has happened. And so that's where AI really comes into play. AI comes into play here where you might have a patient that's been discharged after they have, heart surgery. We need to use AI to do further follow-ups with that patient and ensure that they're getting the constant support that they need from their circle of care. We heard a lot about human in the loop here, so I don't really need to talk too much about this. Everybody's done a really great job talking about this for our business. Human in the loop is very important, especially when it comes to healthcare. We need to ensure that the practitioners are always working in parallel with the AI systems that they're working with. We've developed an AI operating system, and so this is where we're very excited as a company, because we see where we can bring the sovereignty, the modeling, the knowledge store, the orchestration, that's those agents, that autonomous agentic solutions that we're hearing about here this week, bringing that into an operating environment where we're focused on trust, we're focused on governance, we're focused on sovereignty, and we use this solution that bubbles up to those AI surfaces that practitioners and clinicians will use in healthcare going forward in the future. So putting it all together, we're building AI at the speed of trust. And a lot of folks say we're currently in the era of AI. Personally, I think we're heading towards the era of trust. And these agentic solutions that are running out there are going to need that trust. We're going to need that modeling, understand the trust before we allow it to go ahead and enter into the healthcare. Others have done a really great job talking about this today, and I think that this is something extremely important that we need to focus on as a group. So with that, healthcare is difficult. Data is deeply fragmented. Policies differ between jurisdictions, and systems lack compatibility. We all know that data is incompatible. It's difficult to do relational comparisons between different jurisdictions. All of these things, the agentic and the AI solutions can help us with, but we need to ensure that we're making sure that those systems have the trust and have the governance in place before they are deployed. QR code is for our company. Feel free to take a look at what we're working on. I want to say thank you to Dr. Woodland for giving us a chance to talk about this and how we're bringing the implementation infrastructure to the equation. Questions? If we have time.
Thanks so much for attending. And we're going to move to the next session, which started 2 minutes ago on robots and sensors. Please track down the speakers for questions. Thanks so much for attending.